Now we want to differentiate this first function, f of x, to be 3x using the first principle, all right? So we will be considering the limit of f of x plus h minus f of x all over h as h tends to 0, where this h is just a horizontal distance. Good. Okay, so let's see. This is the function we're given, all right? And to use this gradient function, we need to get f of x plus h, all right? We need to get f of x, which we have already been given, and then this h is just what we'll be substituting all the time. Good. All right. Now look at this. If f of x is 3x, then f of x plus h will be what? F of x plus h. Now, from the given question, f of x to be 3x, right? So what you can see here is that this is written in terms of x, and the only place that x appears is at the back of 3, right? Just 3 times x. So what we'll be doing here is that we want to rewrite f of x plus h in terms of this, right? This will just give us 3 times x plus h. Again, when we have this to be the independent variable, it just happens as a multiple of 3, all right? So we put it down there as well. Good. And now that we've gotten the f of x and the f of x plus h, we need to apply each of those into this limiting notation. So the derivative of this function, which I can put it down as the y, the x, right, will be the limit as h tends to 0 of, now, f of x plus h, which is this, which has been given to be 3 times x plus h, right? Then minus f of x. F of x here is just 3x. Then we divide everything there by h, all right? So we put down the h in front, at the bottom. Good. Let's simplify these things a little bit. Remember to put down the limiting notation. The limit as h tends to 0 of, well, we can expand that bracket. We can open up that bracket. 3 times x, that will be 3x. 3x minus 3x, that is going to be 0. Then 3 times h, right? So we simplify the numerator. We are going to enter with 3 times h. Then we divide that with h, right? Good. Well, this gives us, since we have 3h divided by h, this and this will cancel, and we are just left with 3, right? Good. Now the limit, let me put it down here, the limit as h goes to 0, or as h approaches 0 of 3. Now, this 3 is just a constant, all right? It has nothing to do with h. So the limit of 3 as h tends to 0 is just going to be 3, all right? Good. So that is just 3. So 3 right there, which is the limit as h tends to 0, okay, is the same thing as the derivative of y respect to x. So I can say in conclusion that the y, the x, is now equal to 3. That is what we get from first principle. All right, good. Okay, let's go over and solve the second one. So you have the second function to be f of x equals to x squared. So you want to differentiate this function just from first principle. Good. So what we need here is f of x plus h. We've been given f of x already, which is x squared. So to find f of x plus h, just from the function rule, okay, so this will be f of x plus h. Now, f of x is the square of that x, right? That is what f does. When you give it anything, it will square that thing. Good. Now we've given it x plus h. It will do what? It will square x plus h, right? Good. And when you square that, we can do a little expansion there, right? So you multiply out the bracket, you're going to enter with, or you square that bracket, you're going to enter with x squared plus 2xh plus h squared. So that is what we get by expanding that. Good. And now we need to substitute everything into the gradient function and take the limit as h tends to 0. So we're going to write it down this way, that the y, the x, right? Let's see that the function, the x squared is y, right? Remember we say, let y be f of x, or if y is f of x. So the y dx will now become the limit as h goes to 0, or as h approaches 0, of f of x plus h, which we've discovered it to be the whole of that, which is x squared plus 2xh plus h squared. And again, minus f of x, all right? You put the minus, then f of x is just x squared. Good. And then we say divided by, in the denominator, just have h, right? Okay, so here, we're going to take the limit as h tends to 0. Now, see the simplifications here. X squared minus x squared, they are both equal and opposite in sign, so they will all get to 0. And we enter with 2xh, right, plus h squared, all divided by h. Good. So we want to take the limit of this as h tends to 0. Well, look at that. We have h in the two terms in the numerator, and we have h in the denominator. We can factorize h from the numerator, and that will cancel out with the h in the denominator. So we're going to enter with the limit as h goes to 0 of 2xh divided by h, that will just be 2x, plus h squared divided by h, that is going to be a single h, right? Okay, great. Now as h tends to 0, 2x has nothing to do with h. So h going to 0 will not affect 2x, right? Because there is no h here, so nothing is going to 0 here. So we just put down the 2x first, and then plus h. Well, as h approaches 0, this place is going to be approaching 0, all right? So we just take it to be 0 at once. Now, 2x plus 0 is just 2x. So I can put it down here that 2x here is the derivative of that function with respect to x. Okay.